Hello again, welcome back. My name is Al, and this is a C++ tutorial series, the continuation of lesson number 111, I should say, wherein we are going to go back to basics and have a closer look at console applications, which typically start out like this. One doesn't normally have a common lib. You would have something like this. That's standard I/O. Just a compile, I think. Oh no, you need T card or something. No idea. What do I need? Oh, Windows. Okay. No problem. Oh, it didn't succeed. Now I need a T card. Something T card. Cheap. What's it, T card? Okay, compile. There's a couple warnings here and there. Yeah. Now, oh yes. Well, no. Normally you wouldn't be linking with special magic things. So take that away for a minute. Now, there you go. Let's go to this configure. Oh dear. Just want to get rid of this for a minute. So in our debug Unicode world, if I build this, I need a build, and then a couple of warnings here and there. But no problem, it built. See, there are nothing to worry about here. I hope. Win32 WinNT is not defined, replacing with 0. I wonder why it wouldn't be defined in Llewellyn. Anyway, the reason why these warnings are showing up is because unlike everybody else in the world, I have all optional warnings enabled. So we'll just ignore them for now and go back to our little program. And what this does is it prints out the very first element of this string array. Now, this is the way people typically, people will write it this way, I think. Actually, no. The typical way people write it is const, if they're going to use const at all, tconst star. Something like that. So this is an array of pointers of T car stars. And so the first element is a T car star. That is a pointer to string. We print it out. And the first element happens to be the program's full path. Okay, fine. Now I made changes. For one thing, I took the real name and put it into a lib. And I took all these normal includes and put them into a single file. And in that file, I have disabled one of these files. And I've disabled some of those warnings that are relevant to us. But there are still many extra warnings available that weren't available without the optional warnings enabled. I compiled this so I shouldn't get any warning. Okay. Now, in making a console, in this case a unit test program, that does something useful, a tool of some sort, you're going to want to use these argcs and argv things. Okay. Now, I don't know, but if you go to source for poor friends at source for that horrible, awful project I was working on for the longest time, I noticed that they make use of some code, some very old code that must have been written about 1972 or so. Well, no, I guess it's in C, so it had to have been written somewhere around when C was initially invented. And it is in pure C. No, I altered one of them here, and it's called get_opt. And what they have is internal handling for argc and argv. There's a lot of code in here, and they've been using this code, and they still use this code to apparently simplify the use of those argc and argv parameters. What they do is they define a construct, and then they call this parser thing, and it returns something in this args variable passed in, and then you can use the arguments as you would, without having to worry about things like which of the arguments are flags and which of the arguments are arguments, and so on. And so there's some automatic handling. Well, I had a look at this code, and I actually tried to use it. First off, it doesn't support Unicode. Second off, it allocates memory that you have to free. So it's not automatic in that sense. It uses strlen and strcopy and things in an unsafe manner. Let me show you some examples. I think so. I think so anyway. Now see, I don't know what this does. It's a very difficult thing to try to make sense of because it uses a lot. It makes a lot of use of number defined. These are global variables, okay? OPT, OPT. There's no static here. So nowhere else in your entire project are you allowed to define, well, you could define a variable with this name as an argument to a function or something, but certainly not as a global, or else you would get a conflict. Here I've used static, opt, and all these things, opt are global variables. So that's one bad thing already. Maybe that's what I needed. Maybe that's what that user DLL thing was. Okay, so that's that. Now that's part of it. Notice this is pure C, not C++. Now there's so much code that they had to split it up into two files. Here's the second part, where once again it's pure C. There's testing code here. I suppose that if someone wants to learn how to use this opt-arg stuff, they would define the word test and then run through this example and see how it works. Well, I tried that and I couldn't figure out how it worked. Too complicated. So instead, I have my own thing. Since we're in the year 2013, we no longer need to use C, pure C, although pure C it can be used, you're allowed to, and it compiles very quickly and produces efficient code. In fact, this one here is this declaration is for a C function, but I can use C++ in it. This being a C style function, anything can go here and it'll compile. Well, except there's no argv anymore. Of interest, perhaps, if you're interested, to find out where that gets called from. This is part of the actual C runtime library. You can tell because it doesn't look anything like what I would write, which is split up into 2 bits. Something with 2 underscores called that, and then this with 1 underscore called that, which eventually calls the other one. And now this does some setting up for you. What it does is it gets some operating system information. If this was defined when this was built, then this would be a Windows program, but we're not. We're a console program. So, but still, all this code See, that only ends here. So this happened. Heat alloc was done. The operating system version was determined. These have been saved off and are in what I assume are global variables. So if you say win major anywhere in your program, that should be a number. Hopefully, this is not a global, but I bet it is. Let's see. That would be a pointer, wouldn't it? Oh no, it's a number. That should be the operating system version. No, okay, so that's internal. Some of these aren't internal. I don't think this is internal. Yeah, it is okay. They got, so, you know, the people at Microsoft are a little bit smarter than people at SourceForge. They don't use, like, anyone would make up a variable name with a name like that, right? You wouldn't want to use this as a global variable name. Because that's, you know, the first thing that somebody might type for a Windows version. Okay, so then some heap stuff, this and that, initialize, blah, blah, blah. Win main is not defined, so that puts us in this part. And where was our call stack? Gone. And here. Okay, now, so that puts us here. Not win main, so there's no t win main call. So you can see that all it does is it calls main with these three arguments. Most people only include these first two. This is a count of the number of strings on the command line, including the program, full path of the program, which it typically is not on the command line. argv points to provides pointers to those strings, and this provides an array of pointers to the environment variables for the current environment. Okay, that's fair enough. Now how can we use that fact in order to save ourselves the headache? How do you deal with something like this? What we want to do is split it up. Typically split it up into arguments and switches. So I'm in a special class for that called TsCmdLine. Here it is here. Why is it checked out? Oh yes, I fixed that. Yeah. I add to these things as I go along. This is one of the few classes that I've ever written where pretty much all of the work is done in the constructor. And there are 4 constructors. 1, 2, 3, 4. the first, the one everything is based on, takes 4 arguments. First is the address of the argc value from name. So that's the address of this. This is not used. I usually give this a name that I'm not going to try to use the variable name. And that's the name of the structure. And I usually call it TsCmdLine. No, that would be good enough as it is. No, I'll leave it like that. So this is the simplest form of the constructor. There's no default constructor. It needs to know at least the address of the argc bit. Okay, I'm not going to call this argc, and we'll see why in a minute. We'll print something out. I'm going to print out argc. So it's already got a member called argc, so we can extract argc from it. Oh, I'm going to get rid of that. I'm providing a command line. Assuming there's no command line, I get argc equals 1, which is correct. Well, where's argv? Well, argv is still there. Now the way it works is this. I can step through it if you want. Why not? What I'm passing in here is actually a pointer. You'll notice that this doesn't say int. It says int reference. Okay, now reference is a pointer. So what I'm passing in here, $, is really the address where argc is stored on the stack. Okay. There are some lists in the struct, so it's initializing them. Okay. Now, all of these eventually just call the same constructor. The default constructor takes again an address to an argc thing, a character that's to be used for a switch, like slash or minus sign or something. Whether or not it's a case-insensitive type thing, if you want the comparison to be case-sensitive or not. A pointer to your list of valid switches for the program, and count the number of strings in this array, and a boolean which says whether or not to attempt validating the command line to see if it's a valid command line for the program. Now I'm adding one switch to this object, the question mark. I'm using / as the switch, true meaning case insensitive. These are the switches. False meaning don't validate. And you'll notice that appears as though I'm missing something, right? And that's because there are two things here. There's the construct I just showed you, which has a counter value for this, but using the same name, I have another thing which takes one fewer arguments and a reference to an array of string, so that I can pass this array value in, and it already knows what the count is. Okay, I've used a lot of time, haven't I? Well, that doesn't matter. Okay, so now this I'm pretty sure you understand. Now this is going to use the template version. Let's say, we'll see when I hit F8. It just went, okay, the compiler automatically figured it out. Count, count is 0. Why is it 0? Validate is true, that's what I said. There's no 0 here. That would have had to gone. Let me put a breakpoint here and make sure. I want to make sure that it went here. Oh, wait a minute. Let me just validate. It didn't do that at all. That's why. It didn't use the template version. It used the other version, but the other version has these evil default arguments. Be validate, which is true. But I've set it to false. I got the right number of arguments. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. I probably got a bug. We're going through this. It's been a good exercise. I found a bug. For one thing, I haven't passed the size of my array in. So this should say 1 and false. Well, in fact, I had a bug. We'll double check all the rest of them. These ones are using the template, so I don't worry about it. It's only the default case where I had that bug and now I don't. So let's try that again. F8. 1, correct. In fact, it doesn't matter. Because I never use question mark as a switch. Never. Through the mechanism. I'll accept minus question mark or slash question mark as meaning you want help. Doesn't matter what you say. Okay. Now the way this thing works is it uses the variable argument stuff in order to find the argv pointer. Okay. So I declare they call these this thing as VA list, variable argument list. This VA start is a macro, and that corresponds to this. And all this does is take the address of this thing passed in and add the size of it. So that gives you the next argument in the list. Okay. So I started at argc, which is a pointer, and now VA list should be pointing at the argv part. So here I have const lt blah 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 equals this. What does this do? Plus equals size of t minus size of t. Okay, there's some rounding going on to make sure that everything rounds to integer sizes. And there's a cast. So if you take the current argument pointer, add the size of the type, which is a pointer in this case, using this macro, whatever this does. So this rounds to D where it looks like. And then subtract that same size away. That should give you back, that should step you to the next argument. So I guess the first part didn't take us to the next argument. It took us, all it did was it set up this AP variable for us, which should have been the address of argc. See how complicated all this is? But it's not complicated in the sense of ununderstandable. It's standard C. It's just that somebody went through the painstaking process of figuring all that out and making sure that this works. And the way it works is you say VA list, and you give a name, then you say VA start, give your variable name, give the name of the variable for which you want to start your variable argument searching, and then you just keep calling VA arg to get the next argument from the list. And you have to get past in the type of that next argument. Now I know that the next argument after this one is a pointer to strings. And so I've extracted it. Here it is. And it's pointing to the first element is certainly correct. And I know that the next argument, because we looked at main here, is a pointer to a bunch of strings, environment variables. So I'll take that one too. And it turns out the first element of that string list happens to be this. It won't help us anymore. But we can walk through them. Okay, now I don't know what argc is. It turns out that it's 1. And I'm going to walk through. Now, if the argument I even want to use 0, but anyway, the first one's this is going to be false in the first case, and there's no second case. Okay. So if I find a minus question mark or a slash question mark anywhere on the command line, I'm going to set a boolean called help was requested. Now I'm walking through again. Now I'm looking at the first character for each of the arguments and comparing it with my switch character. Now, if it's not equal to the switch character, which it's not in this case, it's the name of the program, so it's not slash. I add this string to a linked list. See, I have 3 linked lists, one containing all of the arguments, one containing all of the switches. This is a special struct which has a name, a value, and possibly something else, and the environment variable. So I add that one. There's no 2, so we're done with that. Now, I don't know what to count on the environment. I was able to use argc for my linked list of argument strings, but it turns out for the environment variables there's no count provided. But I happen to know from experience that it's null. The last pointer in that array of pointers is null. So I just keep going through, adding to the list. You can see this list is, it's got 5 elements so far. Accessories was that first one we saw, and then all user profile, app data, batch assembler, batch path. Eventually we get to here. Curious how many? 72 in total environment variables. Lots and lots. Probably some of them don't need to be there. Yeah, I don't know why. Oh, because this inherited the environment where I launched this from. I launched this from here. I have to add a batch file. Okay. Now, where are we to validate the switches? The answer is false. We don't. So now we're done with that. Okay, now I should have showed you that. Let's just see how to, obviously, to get argc, all I need to do is return the length of that list. And I've called that list argv, strangely. Okay. argv is just a constant reference to a list of strings, the argument list. I've also got one called np and a thing for switches. Okay. So, and now I'm just returning the count. And the count is 1. Okay. Now I could also say I could extract the first element in my argvs. If I wanted to, I could do it like this. Get fine for 0. Yeah, that would work. But now that's a TS string. What's the function that returns me the object besides bracket? I have something. Oh, get head or something. I don't want to pop it, I just want to get it. Get ahead. I think that's yeah, it returns a reference to a T object. And you have to make sure to cast that to a string. So I still have my argvs, okay, and I've got my argcs and everything. And we've gone through the pain of looking at the first simplest constructor. Now it never has to be done again. And now I'm going to just tell you that an alias for argv is square brackets. And I can do that instead. That also works. Okay, so that's argv of 0. If I had more than one argument, so there are actually 3 arguments there. I could do let me walk through the argument and print out argv of some number equal to string. Now argc will be the count of the number of strings. No, we'll call this C, small letter. Of I. A lot of people like to use I before this. So argv of I equals %s, and I just say command line of I, and just turn it into a C string, or I'll say a crap. And there we are. There were 4 arguments. The 0 is the name of the program, and then the 1 was ones I typed in. Okay? Next tutorial, I'm going to show you some of the more advanced features of this command line object. The only difficulty in this is explaining how it works. Certainly not in explaining how to use it. This is easy, right? This is already already a slight improvement over what we had, because we don't need to declare anything here. I don't even need these dots. The fact that there are arguments after that it's none of my business. I don't need to know it, right? If only there was some way I could automatically, insert that $sign in here, I would do it. Okay, so next time I'm going to show you some of the other constructors.